Okay, thank you for being here. What I will try to do is to give a little bit about the scientific background, the problems for the project landscape scale investigation of greenhouse gas exchange, LAGGE. I couldn't possibly explain all what we are doing, so I will just give a snapshot of some parts of it. And after hearing the comments earlier, I will see whether I could do some commenting and add to what Johan was saying and to what Cederqvist was saying. But really what we are interested in this project is to look on the greenhouse gas emission and the balance. We're interested in the matter transport, and we're interested in this between land and atmosphere, land and water and atmosphere. So we are thinking in a catchment mode, just because we have to do that. We try to develop and use new technologies. We want to use this to improve models. And finally, our intention is to compare whether our models and our measurements are correctly integrated by having airplane flights over the catchment. So this is the ideas, and as you can understand by saying this, you need a large team, and we have a very large team of excellent scientists, so I'm the coordinator of this, and I'm very pleased over this because I have some of the best colleagues in Sweden, and we are currently, when I did this setup, it was 8 universities involved. I think we now are up to 12 universities that are involved. So I say, and more. And the project is financed by Formas, but also to a very large extent by the research area BEC. So we have, luckily, have a good support. Now, what is the problem? Why are we doing this? Well, from this global budget for the whole Earth, we could see that we have a terrestrial sink. We know how much that is emitted, we know how much that is the sink in the sea, and we also know the total increase of carbon dioxide in the atmosphere. So we ought to have this sink. And then we have taken away the carbon that is emitted due to that we had deforestation. So we have a good sink in this terrestrial ecosystem. And we know that to a large extent this sink is in the boreal region where we have the boreal forest. So what's the problem? The problem is that when we have an uptake of CO2 in the vegetation, we also get an increase of the carbon in the soil. And as we heard earlier, that was maybe good, but also the way that Johan commented, we don't get that much of a build-up. And the reason for this is that we have a transport out from the terrestrial ecosystem of carbon. That could be in the form of dissolved organic carbon, it could be as particulate carbon, and to some minor content as dissolved inorganic carbon. And going back to something that I haven't mentioned here, but links a little bit to the earlier presentation, we also have a transport of dissolved organic nitrogen out into the system. Now, what happens when this carbon comes out into the limbic ecosystem is that we get an emission of carbon dioxide. So we emit what we have fixed. And we also have an emission of methane out of the system. Now, if we have to do the same thing as was done earlier. We need to calculate it over to CO2 equivalents, the methane, to see what the effect is. Now, 2 of my colleagues within the project had looked on how much these emissions could be if we put it in the global context. And it's a little bit scary. Because if I add the CO2 and the methane, using this CO2 equivalents, 80% of the fixed carbon, of the carbon that goes out, and that is fixed by this ecosystem, goes out here. And this is from 2 science articles. Now, if we forget the methane and we just look on the CO2, I say, no problem, because we have estimated the sink here by a global budget. So if we have a source here, it is not a problem compared to the sink. However, it is a major problem when we should say, how do we manage the land? How do we handle this transport out of the ecosystem? Then we need to know this. More problematic is the methane, because that we don't have calculated into the CO2 budget. It goes into the methane budget, and then we talk about other mitigation actions. So this is a little bit about the background. Now, GESA made a comparison between the amount of organic carbon in the lake system versus the amount of organic carbon in the soil in the catchment area at a large number of lakes in Sweden. You could see how nicely the organic content in the soil fits with the amount that is emitted to the lakes. And this is a 1-to-1 line, and you could see that this line is way over here, which means that maybe a per mil of the amount of carbon that is in the land is emitted, and that's reasonable. Now from this, one could say that okay, then we know how to handle the land. But that's not the truth, because we need to understand how we should manage the land within each of these points. But we know that it's linked to the organic matter in the soil. So we set up to investigate this. We started a large project, and we started it at the Skogaryd station. Skogaryd is located between Vänersborg and Uddevalla. The reason why we selected Skogaryd was because we, since 2006-07, has started to investigate an drained former agriculture soil that has a first generation of forest, and this forest is growing like crazy. And we decided to put up more towers at this site, micromet towers, in order to estimate the fluxes. So it was a good site for doing this. What we had at this site was a peat ecosystem. We had different forest ecosystem. Over here we have a clear-cut site, we have the drained organic soils, and we have forest on mineral soils. And on all of these we could study the exchange between land and atmosphere. We also had a set of lakes located, and we had stream within the area. And it is large enough so that we could use the ultralight airplane from Lund University to integrate over the area. And it is possible to do all of these investigations. And the reason for that we could do this is that it is all within the same catchment. So we were lucky. And we were really lucky because we looked for the organic site. After that, the storm Gudrun had taken our sites in Skåne, and we selected this site over here, and it happened to be in a watershed area so that we could do all of these integrated studies. So I will shortly show you some type of instrumentation that is needed to do this before I come to some of the discussion of the flows. So this shows the equipment that we have set up at Lake Ersjön, the first lake after the Mire. So we put up a micromet tower. We have sensors for measuring methane, CO2, and the wind. We also have equipment to measure the profiles in the water. We have floating manual chambers, and we have automatic chambers. And as you can see, there are several teams working at each of these sites. So this is able us really to measure this estimated flow directly when it comes out from something. And just to move upwards in this, we have the Mire system. And at this Mire system, we measure the exchange of the fluxes by micrometeorological techniques, like at the lake, but we also have manual chambers, and we look into how much organic matter that is produced and in which form it is, how available is it for degradation, and how much is transported out. And that is the next step. We measure the flow out, and we do that with several of these automatic stations that we have set up at Skogaryd, where we measure the flow, but we also measure the concentration of different matter that is in the stream and look on the quality. So we can really close the system. Now, I don't have any data ready because most of our measurements started 2012 for the whole integrated part. But I would like to return to an investigation that I was part of that took place up at the Degerö Mire. And Degerö is located in the vicinity of Vinden. Now, NEE, that means net ecosystem uptake, and that means how much carbon that is taken up by the vegetation and transported in. TOC stands for total organic carbon, in this case, in the water. What we saw was that roughly 30% of what was fixed by the Mire was going out to the water system. And that's a fair amount for a system that should be pretty close. But what was more striking was that these annual variations that we had in the outflow was linked to the discharge rate. That goes to how much water that goes out of the system, not to the concentration that was in the Mire. And what that means is that the more rainy weather you have, the more carbon will go out of the system. And the negative thing with this, in a long-term perspective, is that when you have rainy condition, you have less NE. So you have less building up and more flooding out. I will take this as an example because I will also link to a whole set of other studies that has been done in Sweden when we talk about forest ecosystem, because the same thing has been found for forest ecosystem. The flow out of carbon from the ecosystems are linked to the amount of water and how high the groundwater level is. So if you have flooding events and you have the groundwater going up high, you will have a lateral flow at the surface. And it is in the surface layers that you have most of the organic matter. But not only that, you have a flow in the surface layer. At the occasions when you have this flow, the water goes over the riparian zones at the surface. And riparian zone, that is the wetland areas next to the streams. So the carbon is not captured, which is normally is in that. So it's an overflow similar to when you have a sewage plant and they have an overflow. It's the same thing with these type of systems, and you get them episodically out. And this also goes back to our management, because when we have a clear cut, we get a raise of the groundwater due to less evapotranspiration, since we don't have the trees there. And at the same time, we have a lot of litter left on the clear cut site, and we have the fine roots there. So we have more of a transport. And furthermore, at these clear cut sites, one often do what we call remediated drainage, and that simplifies the transport out. So we have problems with this. Now, I said that forest was a net sink. This is not true for all ecosystems. and I will take up the drained organic ones. The reason why I take out the drained organic ones is that we have 700,000 hectares of drained organic farmed land around 1930. We have 300 now. And the Skogaryd where we're looking at is a drained former agricultural land that has been planted. Now if we look at the carbon budget on this, the tree fixes 8 ton carbon per year in both above and below ground. This is enormous. This is as Sune Linde would have his model experiment for fertilizing the forest. This is an extremely well-growing forest. But we use 2 different techniques to measure the uptake of CO2 from the atmosphere. When we did a budget way of doing it with chambers, we came to ±0. When we used the eddy covariance, we came to -2, but we have a problem with that technique because we underestimate the nighttime fluxes. But regardless of this, if you look on these figures and you look on the figures on what the tree has fixed, we have had an enormous flux of carbon dioxide out of the system. So what you could say is that we has transformed peat carbon into tree carbon. And that is fine if we look on the budget as now, because it's about ±0, I would say. So it doesn't affect the radiative balance currently, but it will do it when we start to use the forest. So the question is, what should we use that forest for? If we burn that forest for biofuel, that would then be equal to burning peat. And peat is not what we classify as a renewable energy source, but it's worth. And now we'll link into what Crystal was talking about. In terms of methane, we had no emission whatsoever, but when it comes to N2O, we had an emission of about 7 to 11 kilo per hectare a year. That's in the lower range of if we would have had it as an agriculture soil, as an organic soil. A clay soil would maybe emit something between 1 kilo and 2 kilos. Now, if I turn this into CO2 equivalent and then turn it over ton C, I will end with this. So, my conclusions for this type of soil is that these afforested soils are most likely a net source for greenhouse gases as they are today, without taking the DOC into consideration. They are hotspots, and they represent 1/3 of the drained forest land. And if we would look at the N2O emission from these soils, they contribute to nearly 20% of the total anthropogenic emissions. The rest is mainly coming from the agriculture sector. So a way of taking these organic agricultural soils out and reforest it is definitely not the way. There are other alternatives that we can discuss in the afternoon that one can do. We are not ready with the mineral sites yet so that I could give you a budget, but they will definitely be more positive. And what I would like to end off with as a question is, what are the implications for management of land, forest? So that links both agriculture and forest I would like to bring in, and link it to the water in a changing climate. Because we need to handle it and think of it, and we need to think of it as a catchment level. A little bit of that was presented in this agroforestry, and in the what Crystal ended with, we need to look at on the landscape. But we need to combine them. So, thank you.
Thank you, Leif. Thank you very much for a rich presentation. And I'm sure there are plenty of questions. Yes, they are waving already. So stay with us up here and respond to is it Christine first?
Yeah, my name is Christine Lipta. I'm from Chalmers University, and I was wondering whether there are already models out to simulate this NEE flow, where you could, for example, simulate how is the flow changing when I start increasing the harvest, or how is the flow changing when I start taking out lodging residues and this kind of things. Is something like that already there?
Yes. We have a set of models looking at this. There's a whole set of models modeling the forest. The problem is to have models that links the terrestrial system with the limnic system, and that is two tasks that will be done by Uppsala University when it comes to the limnic system, and KTH when it comes to the terrestrial, and they will be linked. And it is these models that we want to verify with airplane flights.
Okay, Christer.
Okay, okay. I have this question about you say that approximately one third of net CO2 uptake is lost as dissolved carbon. That was something like that.
Yeah.
Is that included when you do this carbon accounting in land use for the reporting of national greenhouse gas inventory? So they give too nice picture then.
They give a too nice picture.
Seems like we have a lot of nice pictures.
And I would like to add to this. I don't think that this figure 1/3, that was from those 3 years that we measured up at that Mire. I mean, the flow out, for example, from a forest ecosystem depends on so many things. So that nice line that Gesa showed, that is the integrated averaged values for the different lakes, and then it became very nicely, but it was a scatter. And if you go into each of these individual sites that you want to manage, you will see that you have a scatter. And it's highly complex because it's a matter of organic that is coming into the soil. The water and the deposition affects the binding capacity and the transport of these organic compounds. And you should view these particles that are going out like nanoparticles. And I think that Martin at the chemistry department described these nanoparticles as buses. They take up passenger, they drop off passengers when they transport, and I would even say it's like a train, because they drop off wagons and they connect wagons in terms of it. And in the end product, when they come out to the water, we need to figure out how easy are they broken down. What is the methane from it? What is what is buried? And what is emitted as CO2? And it's rather complicated. So it's not, I would never say that 1/3. I would say that a fairly large fraction.
Okay, well, we're into the complex. How many of these sites, how many Skogaryd sites would you like to see globally, and how many are there in reality? I mean, to really learn what to measure these things. We are already measuring, there are national reports being done, etc. How many Skogaryd examples would you like to see out globally? That's a complex question.
I would like to see much more than exist. I would say that there exist 2 sites globally. And one is the Krickland catchment up in the northern part of Sweden, and the next is Skogaryd. There does not exist anyone that really combines it together completely. But these 2 sites does it. In Finland we have sites outside Helsinki, but they have the different system.
These are boreal areas, all of the ones you're mentioning. And are there any equivalents out that you know of?
No.
No. Okay.
So we are in the forefront of combining it. There are a lot of sites where you have measured the DUC as such. There's a lot of sites where you do the eddy covariance. But it's rarely that you've tried to put it together. This is the unique with the project, and the unique is also that we are so many people that are specialists on the different things. And we should thank the Gudrun for that. We came to the
storm. That's like Hurricane Katrina, but in Sweden some years ago.